Hello, dear student. I welcome you all to KLS Gokte PU College of Commerce and Science, Belgavi. This is our lecture number 2 on a topic classification of elements and periodicity in properties. Myself, Mr. Akash Vasan Nesarkar, lecturer in chemistry, Department of Chemistry. Students, I hope you remember what we have discussed in the last class. We studied the historic theory of the periodic table, and on screen you are having the modern periodic table. I hope you know there are 118 elements are present in this periodic table, and some of the elements are metal, some of them are non-metal, some of them are semi-metal, some of they are transition element, and some are lanthanides and actinides and etc. So in periodic table there are 7 rows. The horizontal lines are called rows, and there are 18 groups. The vertical columns are called groups. So 7 periods and 18 groups are present in a periodic table. The group first and second are of metals known as alkali and alkali metals. From the group 3 to group 12, these are the transition metals, and group 13 to group 18 are called non-metals, and the elements after the lanthanum and actinium are known as lanthanides and actinides. So this is about some basic of periodic table. You should know the elements belongs to which group. So try to remember the atomic number of the element, name of the element, and symbol of the element. The atomic number 1 stands for hydrogen and its symbol is capital H, whereas atomic number 8 stands for oxygen and its symbol is capital O. In this manner, you have to remember at least 30 elements starting from hydrogen and ends to zinc. You have to remember at least 30 elements for PUC first year as well as second year. Now, in today's class, we will see the classification of elements. The elements are classified into 4 categories: typical element, metals, non-metals, and metalloids. The metalloids are also known as semi-metals. Let us try to understand what is typical metal elements. Third period elements are called as a typical elements because the properties of all those elements belonging to the particular group resemble the properties of corresponding typical element of that group, and this is the reason why they are calling as a typical element, because the elements belong to a particular group resemble the properties, it resembles the same properties of the corresponding typical element of that group, and therefore these elements, that is third row elements, are called typical elements. Next one, metals. Metals are generally characterized by their tendency to give up the electron. Any species, if it gives the electron, it acquires a positive charge over it, and that positive charge resembles like that species will act as a metal, because metal will lose the electron very easily, and if the element is losing the electron easily, then that element will act as a metal, and therefore the metals are electropositive in nature. Metal comprise more than 78% of all known elements. So it comprises 78% of all known elements. So remember, the metals are nothing but what? Metals are electropositive in nature, or the element which gives the electron very readily, that element will act as a metal. Next one, non-metal. Non-metals have a tendency to take up electron to form anions. Means it is exactly opposite to that of a metal. What is metal? The metals will give up the electron, but non-metal, instead to give up the electron, it tried to gain the electron. And by gaining the electron, they form anion. Anions are the species which carries negative charge over it. Cations are the species which carries a positive charge over it. So metals are electropositive, so positive charge will be present on the species, and non-metals, these will take the electron over it and they may form anions. So nonmetals are electronegative in nature. Nonmetals are located at the top right hand side of the periodic table. Means from group number 13 to 18, at the top right hand the nonmetals are present. For example, boron, carbon, nitrogen, oxygen, fluorine, chlorine. Those belongs to all non-metal category. And metals, the group 1, that is alkali metal, hydrogen, lithium, sodium, and group 2, beryllium, magnesium, those are metals. Now next comes, that is very important, metalloids. Neither metal nor non-metal, right? Yeah, let us see what is that. Non-metallic character increases as we move from left to right across a row. So if we move from left to right across a row in the periodic table, we get the metalloids. So some elements which lie at the border of the metallic and non-metallic elements have the characteristics of both metals and non-metals. Example: boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. So these elements will act as a metal as well as non-metal. And some conditions are there, and those conditions we will learn in a second year. Okay, so remember, semi-metals means what? They act as a metal as well as a non-metal at a certain conditions. Okay, remember the example: boron, silicon, germanium, arsenic, okay, and etc. And next one, that is very important, diagonal relationship. Certain elements of second period shows similarity with their diagonal elements in the third period. For example, lithium resembles magnesium. Lithium resemble magnesium. So this is a lithium, its a diagonal element is a magnesium. So the properties of lithium resembles the same properties that of a magnesium. Or potassium resembles the property of strontium, or sodium resembles the properties of calcium. Okay, so relationship is this relationship is called as a diagonal relationship. That is, second period shows similarity with the diagonal elements in the third period. The lithium shows resembles like magnesium, beryllium resembles aluminum, boron resembles silicon. So the second period, so this is our second period, will show the diagonal relationship the first element of the third row. So lithium will show diagonal relationship magnesium, beryllium will show diagonal relationship aluminum, boron will show with the silicon, and etc. So it resembles in their properties. Now this is called diagonal relationship, and it is due to the reason that these pairs of element have almost identical ionic radii. So the lithium and magnesium are having almost identical ionic radii, and also the polarizing power, that is charge and mass ratio. Okay, so due to this they will resemble lithium, magnesium, beryllium, aluminum, and boron, silicon. Next one, anomalous behavior of the first elements of a group. The first element of a group differs considerably from its congeners. Okay, the first element of a group, that is boron or carbon, nitrogen, oxygen, fluorine. Okay, any of the first element of a group differs considerably from its congeners, means their group family. This is due to the small size, high electronegativity, and non-availability of d orbitals for bonding. So anomalous behavior is observed in second row element, that is lithium to fluorine. Lithium to fluorine. So this is lithium to fluorine. So here lithium will show the different behavior. Anomalous means what? Not a normal behavior compared to their family members. If we if I choose lithium, its the family members are what? Sodium, potassium, rubidium, cesium and francium. If I choose boron, then its family members are what? Aluminum, gallium, indium, titanium. Okay, so these are the conjurants, and the property shown by the boron and the property shown by the rest of its family members are quite different, and this different behavior is called the anomalous behavior, means not normal behavior compared to their family elements. Okay, and such kind of behavior is called the anomalous behavior. And the reason to show this anomalous behavior of first element of the second row is due to the small size of the element, due to the four reasons: small size of the element, okay, high electronegativity, then non availability of d orbital, non availability of a d orbital, yes, small size, high electronegativity and non availability of d orbital. Due to these reasons, the first elements of a second row shows the anomalous behavior, means not a normal behavior in respect to of their properties like physical and chemical with that of a family members. Now, let us talk about only metal. See, as I said that electropositive elements are called metals, with the exception of hydrogen. Okay, with except the hydrogen, all elements that form positive ions, all elements that form the positive ions by losing electrons during chemical reactions are called metals. Means, if A is the element, suppose if A is the element from any element from the periodic table, and during the course of the reaction, if that element loses the electron, if that element loses the electron, so plus E minus means it is losing the electron, it is giving up electron, then the positive charge acquires over the A. The positive charge appear on A, and that positive charge is nothing but what? Ion. It may be a cation. Okay, if a negative charge is there, then it may be anion. So whenever the element carries the positive charge over it, it turns into atom to ion because positive charge is present over it, and therefore this positive ion is known as a metal. So all the elements that form positive ion by losing electron during a course of chemical reaction is called metals. So metals are electropositive in nature by losing their electron. Thus metals are electropositive elements with the relatively low ionization energy. So if the elements are having the low ionization energy, if the elements are having the low ionization energy, energy required to lose the electron, okay, if the elements are having the low ionization energy, then those elements are metal. For example, okay, consider the first group, that is hydrogen, lithium, sodium, potassium, rubidium and cesium. As we move down the group, the ionization energy decreases because the cesium will lose the electron very easily compared to that of rubidium, potassium and sodium. But whereas lithium, it do not lose its electron readily. It do not lose its electron readily, and therefore its ionization energy is very high. What is ionization energy? Energy required to remove the outermost valence electron or outermost electron. That is called as ionization energy. So energy required to remove the outermost electron is called as ionization energy. If element has to lose the electron, then it should have the low ionization energy. Therefore, the cesium is having the low ionization energy, and therefore it will act as a metal. It will act as a pure metal, you can say that. They are characterized by bright luster, hardness, ability to resonate a sound, and excellent conductors of heat and electricity. As we know that metals are excellent conductors of heat and also electricity. Metals are solid under normal condition except for mercury. So mercury is a metal but it is not a solid. So students, you may have question here. Being a metal, being a metal, the physical state of mercury is not a solid. Give reason. Okay. Or sometimes in competitive exam they may ask the question like this: which is a liquid metal? Then you should answer the mercury. Okay. Because generally metals are what solids, but mercury is the only one which is present in a liquid state. Now let us see the physical properties of metals. Metals are lustrous, malleable, ductile, good conductor of heat and electricity, as we know that. But the other properties which are very important, that is state. Metals are solid at a room temperature. Okay, this is right. We know that at a room temperature, metals are what? Solid. The exception is what? Only mercury, which is in liquid at a room temperature. Gallium is a liquid on hot days. Another element, that is gallium, it will also turns into liquid but at a hot days. Luster. Metals have the quality of reflecting light from their surface and can be polished. Example, gold, silver and copper, and such properties is known as a luster. So metals have the quality of reflecting light over its surface. Give the example, that is gold, silver and copper. Malleability. Metals have the ability to withstand hammering and can be made into thin sheets. So we can mold the metals into thin sheets known as a foils. For example, sugar cube size a chunk of gold can be pounded into a thin sheet that will be cover a football field. So many examples are there. Ductility. Metals can be drawn into wires. For example, 100 gram of silver can be drawn into a thin wire about 200 meters long. So we can use the metals to make a wire. Hardness. All metals are hard except sodium and potassium, which are soft and can be cut with a knife. So sodium we can cut with that of a knife. Valency. Metals typically have 1 to 3 electrons in the outermost shell of their atoms. So metals can have 1 to 3 electrons in the outermost of their atoms. For example, lithium, magnesium, calcium, sodium. Valency, that is about the valency. Conduction. Metals are good conductors because they have the free electron, because they will lose the electron very easily, right? Silver and copper are the two best conductors of heat and electricity. Lead is the poorest conductor of heat. Bismuth and mercury and iron are also poor conductors. So some metals are poor conductors, some are good conductor. If they give up the electron easily, then they are a good conductor. If they hesitate to give the electron readily, then those are poor conductor. Density. Metals have high density and are very heavy. Metals have high density and very heavy. Iridium and osmium have the highest densities. Iridium and osmium have the highest densities, whereas lithium has the lowest density. So lithium has the lowest density. Melting and boiling points. Metals have high melting and boiling points. Tungsten has the highest melting point and boiling point, whereas mercury has the lowest. Sodium and potassium also have low melting point. Sodium and potassium also have low melting point. So this is about the physical properties of metal. The remaining things about this topic we will study in a next class. So guys, try to read the textbook more and more, and if you have any doubt then you can ask me directly on my WhatsApp number. Okay, start to read the books and try to understand the chemistry. So right now this is the solution for you. Okay, read the book, and if you get any doubt then clarify. Fine. So thank you one and all.